All life on Earth owes its existence to the sun's radiant heat, but what happens when that radiation surges out of control and billions of tons of charged solar material suddenly barrel our way at thousands of miles a second? What happens when Earth takes a direct hit from a solar flare? And could a strong enough one ever destroy life on our planet? Earth's magnetic field and insulating atmosphere keeps us extremely well protected from even the most powerful solar outbursts, while solar storm can tamper with radar and radio system or knock satellite offline. The most harmful radiation is sopped up in the sky long before it touches human radiation. We live in a planet with a very thick atmosphere that stops all the harmful radiation that is produced in a solar flare. Even in the largest event that we are seeing in the past 10,000 years ago, we see that the effect is not enough to damage the atmosphere such that we are no longer protected. Still, not solar flares are harmless, while Earth's magnetic field prevents widespread death from solar radiation. The sheer electromagnetic power of a flare could disrupt power, grid, internet connection, and other communication devices on Earth, resulting in chaos and potential even death. Space weather experts at NASA and other agencies take the threat seriously and closely monitor the sun for potential hazard activity. Solar flares occur when the sun's magnetic field lines become taut and twisted, causing enormous planet-sized storms of electromagnetic energy to form on the sun's surface. We can see these storms as cold dark spots known as sunspots. Around sunspots, huge tendrils of magnetic field lines twist, pull, and sometimes snap, creating a powerful flashes of energy or solar flare. Most energy from the solar flare is radiated away as ultraviolet and X-ray light. However, the intense energy of a flare can also heat up nearby gas in the sun's atmosphere, launching enormous blobs of charged particles known as coronal mass electrons out into space. It is a flaring sunspot happen to be facing Earth, then any resulting coronal mass ejection blasting right toward us, typically reaching our planet in anywhere from 15 hours to several days. You have likely lived through hundreds of them. The sun emits anywhere from one coronal mass ejection each week to several a day, depending on where we are in the sun's 11-year cycle of activity. Most coronal mass ejection pass over our planet completely undetected by the general public thanks to Earth's powerful magnetic field. However, the biggest, most energetic coronal mass ejection can actually compress our planet's magnetic field as they pass, resulting what known as a geomagnetic storm. As electromagnetic energy from the sun pours into our magnetic field, atom and molecule in the Earth atmosphere become electrically charged, creating effects that can be seen around the world during such storm. The aurora borealis, typically only seen near the North Pole, can shift down so far that it becomes visible near the equator. Radio and radar systems around the world can black out and electrical grids may become overloaded and lose power. Some experts fear the sufficiently large coronal mass ejection could create an internet apocalypse by overloading undersea internet cable and leaving part of the world without web access for weeks or months. Though this has not happened yet, satellite and space stations which orbit beyond the protection of the Earth atmosphere can also be devastated by the regenerate radiation of coronal mass ejection. Still, even the most powerful geomagnetic storm in recorded history, the 1859, had no noticeable impact on the health of the humans or other life on Earth. If even stronger solar storm both the planet, path our planet. Before this, there is no evidence that they impact human health. No matter what flare do have a significant effect on us here on Earth. What sort of flux would have to strike the Earth to wipe us out? Our nearest star may not pose an extinct threat, but scientists suspect that our nearest stars could. When certain stars run out of fuel and die, and they explode in a tremendous supernova that blasts powerful radiation into space from millions of light years around. These blasts are many times more powerful than solar flare. Should such an explosion occur sufficiently close to Earth, the dying star could bathe our planet in so much ultraviolet radiation that it strips our protective ozone layer away, making Earth vulnerable to barrage of charged interstellar particles. The death of the star within 65 light years of Earth may have done just around 359 million years ago at the end of the Devonian period. A mass extinction at the end of the period resulting in the death of 70% of Earth invertebrates. Though scientists are not certain what triggered it, and however an examination of fossil spore from the time of the extinction revealed the sign of ultraviolet light damage, suggesting that perhaps an exploding star triggered the extinction. Fortunately, there are no supernova candidate close enough to Earth to pose such a threat anytime soon. We have only our warm little sun to worry about, and our atmosphere makes sure that we stay on the dead star friendly side.